Okay, hello and welcome back to JTT Math Easier, Calculus 2. Today we'll be talking about hyperbolic functions. Hyperbolic functions should be a little bit easier to grasp and understand, especially since a lot of the derivatives are exactly as sine and cosine, first that they have an h, which is the hyperbolic. That makes it a hyperbolic function. These are the hyperbolic functions. The only difference between these ones are that hyperbolic sine and hyperbolic cosine have the power to the e's. Remember that I know my professor in my last exam used these instead of all these because obviously these are a lot easier to memorize. And I forgot what problem he used it, but he used it for a good problem, and it was kind of difficult if you didn't know what you're doing. And then also these are the formulas you have to memorize too. They're important too. They probably show up for your test when you do some kind of integration and substitute and all those good fabulous stuff. So for the first one, it should be easy. It shouldn't take that long. We have hyperbolic cotangent 5x dx. So in order to solve this equation, don't be afraid of the hyperbolic functions. This is just if you want to think about it this way, even though I know it's incorrect. You don't think you put a little finger over here, eliminate it as a hyperbolic function because hyperbolic cotangent, not cotangent. The hyperbolic of this one is co, and this is 1 over tan. And we obviously know the tangent. We obviously know the tangent is sine over cosine. So cotangent would be cosine over sine. But since we're talking about hyperbolic functions, remember to add the h's everywhere. So that makes it a hyperbolic sign. That makes our equation hyperbolic. So remember to add h's. If this gets you confused, then you can do it that way, the way I just showed you right now. But remember to add it because some professors are probably nitpicky or show your work and everything. So make sure to do that. So the first thing I will do is I will rewrite this whole equation right here. So since we said it's cosine, hyperbolic cosine, that's going to be my top, my numerator, and my denominator is going to be hyperbolic sine of 5x. And we're going to do a simple substitution. So my u is always going to be hyperbolic sine 5x. And my du is going to be hyperbolic cosine 5x. But let's not forget that in here we all have to do the integration, so this will be 5 dx. And we want our dx by ourselves. So we're going to go du. And once we can do 1/5 out here, obviously that's going to go to the bottom, hyperbolic cosine of 5x. And it goes dx. We're going to just rewrite this all over again. So it's going to be cosine, obviously stays the same, because remember we always substitute the denominator. So this is going to be my u, and my du is going to be this whole thing. And my dx, I'm going to replace it with my du, so it's going to be 1/5. And if you want, you got the du, it's up to you. Cosine, actually add it. Hyperbolic cosine 5x du. So obviously, by writing this all out, this eliminates and this eliminates. The 1/5, don't forget to carry it out because it's just a number. So we go 1/5. And what we're going to be left here is du over u, which we should all know by now. It's not the natural log, it's the ln. So we're going to go 1/5 ln of u, and our u again is this whole thing. Put absolute value, hyperbolic sine 5x, finish absolute value, plus c. So that's basically how you solve it. They're all basically the same format. They should be easy integration. It shouldn't be too difficult. I'll show you one that's a little bit more tedious, a little bit more difficult, a little bit more you have to use a little bit more of your brain, figure out the formulas and things like that in the next video. But it shouldn't be too difficult. Like I said in the beginning, remember hyperbolic sine and remember hyperbolic cosine, the derivatives of them, because they will be used probably in a word problem. and remember the other two formulas that I highlighted up there. Hopefully this helped, and the new video should be posting up soon. Thank you and have a good day.